Hello everyone, my name is M.D. Mainuddin. I am going to present today electric circuit 1 and electric circuit 2. So what is an electric circuit? An electric circuit is a path in which electrons from a voltage or current source flow. We have a simple electric circuit here where we have one battery, one switch and two bulbs in series. So what happens when you connect the switch? Electron from the negative terminal of the battery travels through the bulb and through the switch to other terminal of the battery, and the current flows in opposite direction. So current flows from the positive terminal of the battery and through the circuit to other terminal of the battery, and here this arrow shows the direction of current. So for a complete circuit, we need such a path so that this current can go from one terminal to other terminals. Well, to explain a simple circuit, we need few basic concepts from your lecture. So we'll discuss Ohm's law and the non-ohmic resistance. So Ohm's law said that the potential difference across an ideal conductor is proportional to the current through it. So let us consider we have a conductor and the current through the conductor is I and the potential difference across the conductor is V. Then the potential difference V is proportional I, or the V is equal IR, where R is a proportionality constant known as the resistance. And the unit of those quantities are, units of current is ampere, units of voltage is volt, and unit of resistance is ohm. And the symbol we use that is A for current, V for volt, and omega for resistance. Also, we need instrument to measure those quantity. So we use ammeter to measure current, we use voltmeter to measure the voltage, and we use ohmmeter to measure the resistance. Also, we can use multimeter to measure all those quantities. The resistance of all conductor is not linear. I mean, all the conductors doesn't follow the V rules, V equal IR. Those resistance are known as non-ohmic resistance. For example, the bulbs in the circuit we already showed is non-ohmic. So for a non-ohmic resistance, the current and voltage graph will be some sort of curve. It will not be straight. We can connect resistor in series or in parallel in a circuit. But if we connect in series or parallel, then their total resistance will be different. For example, if we have two resistors R1 and R2 connected in series in a circuit, then the total resistance or equivalent resistance or EQ will be R1 plus R2. But if we have the same two resistors in parallel in a circuit, then their equivalent resistance or EQ will be 1 over Req equal 1 over R1 plus 1 over R2. Now let us consider three different circuits. In circuit 1, we have one bulb connected in series with a battery. In circuit 2, we have two bulbs connected in series with a battery, and in circuit 3, we have three bulbs connected in series with a battery. Now, we'll try to compare the current and brightness of those bulbs. Now, what is the total resistance of these three circuits? For circuit 1, we have only one bulb, so resistance will be R. In circuit 2, we have two bulbs in series, so the total resistance will be twice R. And in circuit 3, we have three bulbs in series, so total resistance will be thrice R, where R is the resistance of one bulb. And we are considering that all the bulbs are identical. Now, the current in first circuit will be V over R. In circuit 2, it will be V over twice R. And in circuit 3, it will be V over thrice R. So, if we add more bulbs then in series, then current will decrease. Also, if we compare the brightness, we see that the brightness of bulb on, I mean circuit 1 is the maximum, and for 3 bulb circuit it is the minimum. So more bulb in series means less current and less brightness. So we can devise a formula like I is proportional to 1 over n, where n is the number of bulbs. Now let us consider a parallel circuit. So we have two bulbs in parallel. Now the total resistance of these two bulbs will be R over 2. and the current through this battery will be V over R over 2, and if you solve it, then we have twice V over R. So the current through the battery is twice than a single bulb circuit. But this current splits at point B through two bulbs, and again they recombine at A. So though the current in the circuit is double, but the current through each bulb equal. I mean, it's V over R. So both bulb has the same current, and both bulb will have the same brightness. So sometimes by using current, we can compare the brightness of bulbs. But there are some limitations considering only current. For example, in this circuit, we have two bulbs in parallel and another bulb in series. So if we compare the brightness, this bulb has the highest brightness and they have the equal brightness. Now let's see what happens if we just disconnect one bulb from the circuit. So if we disconnect one bulb, we can see that the brightness of other bulb increasing. But in parallel circuit, we saw that the brightness of bulbs doesn't depend on number of bulbs, because if we have more than one or two bulbs in parallel, then all will have the same brightness. So for example, if we have one more bulb here in parallel, we'll have the same brightness. So we can explain these things by considering the current. By considering the voltage. For example, we have three circuits again here. In first circuit, we have one bulb, two bulb in series, and three bulb in series. Now, the voltage across this bulb will be equal to the voltage across the battery. Here we have two bulbs, so the sum of the voltage of these two bulbs will be equal to the battery. Then voltage of each bulb will be half of the battery. And in this circuit, voltage of each bulb will be 1/3 of the battery. So we have more voltage in this bulb, we have less, and we have even less voltage in this bulb. And similarly, we have the brightness. So we can say that more the voltage, more the brightness. Similarly, in these circuits, both bulbs have the same brightness, also the same voltage, because this point B is connected to the positive terminal of the battery, and point A is connected to the negative terminal of the battery. So the voltage across this bulb or voltage across this bulb will be the same. So as they have the same voltage, they will have the same brightness. So in parallel circuit, we can see that the voltage is a measure of brightness. But remember one thing, by considering only the current or by considering only the voltage, we can't explain a circuit. To explain a circuit, we need the concept of both voltage and current, which we will discuss in the lab. Thank you very much.